In this question, we've got a collection of 4 points, and we want to put them onto a quadratic. So not quite a line of best fit, but we're looking for a parabola of best fit in this case. So it's very, very similar to how we do a line of best fit, except we just have to fit a slightly different pattern here. But if we were to plug in each of these points, and I'll maybe just label them P1, P2, P3. I don't know why I started with 2. So P1, P2, P3, and P4. And if we were to plug these in, we would generate a system of equations. So basically, if I plugged in P1, I have 1 equals, and so that's A times -2 squared plus B times -2 plus C, which tells me 4A minus 2B plus C equals 1. And then similar for the 0, 0, I would have 0 equals A times 0 squared plus B times 0 plus C. So this would tell me that C equals 0. P3, so I have 2 equals A times 3 squared, B times 3 plus C. So I get 9A plus 3B plus C equals 2. And then finally the 4, 3. So when I plug in 4, I get 3. So I have 16A plus 4B plus C equals 3. And so this is a system of equations. So basically what we are solving here is 4, -2, 1 times my ABC, which will be my x vector, 0, 0, 1, 9, 3, 1, and 16, 4, 1 times ABC is equal to 1, 0, 2, and 3. So in the language that we use to solve these systems of equations, this is my A, this is my x vector, and this is my B vector. And so what we want to do to get this set up is we solve the ATA formula here. So I'm going to set up my A transpose A, and it's going to turn into x hat instead of the x arrow, because it's not going to be the actual x that we solve for here. But then the right side is A transpose B. So we're going to put in this matrix, transpose 0, 0, 1, 9, 3, 1, 16, 4, 1. And the matrix for -2, 1, 0, 0, 1, 9, 3, 1, 16, 4, 1. And then there's my ABC. And then equals, so A transpose 2, 0, 3, 14, 1, 1, 1, 1. Oh, that's not 14, that's 4. And then times the B. Okay, so I'm not going to do all these calculations on my own. I'm just going to use some software to reduce these. So for this product, I've got 353, 83, 29. And then the bottom section is 29 and 5, and then 4. And so that should be my ABC, which is, I'll just use the x hat for that. And then the product here is going to be 70, 16, and 6. And again, I'm going to use software instead of trying to solve this any other way. If we've done this correctly, that matrix over there is hopefully invertible. So I'll get 353, 83, 29 to the -1, and then 83, 29, 5, 29, 5, 4, and then 70, 16, and 6. And then I used a website called reshish.com. I don't know why it's called that, but it's pretty handy. And that will give me this inverse. And it's just a bunch of horrible fractions. I would not have wanted to work this out on my own. So 91 over 4248 and negative 187 over 4248 and negative 71 over 708. And then it should have some symmetry here. 571 over 4248 and 107 over 78. Sorry, 708. And again, with the symmetry. And that last entry is 93 over 118. And then I'm going to multiply that by 70, 16, and 6. And, oh, those are not x bars. Sorry, those should be x hats. Closest thing to the x bar that we're looking for. And then finally I do this product. It's not as bad as it looks. We get 137 over 108. Or sorry, 708. Negative 17 over 708. And 15 over 118. Again, I did that calculation using the website. It's just matrix.reshish.com. And so yeah, so that's my x hat. And so that means that the best possible solution is going to be this system, or this equation, where my ABCs get swapped out. Oh, shoot. I'm just going to move this over and write out my solution. So so my A is 137 over 78 x squared minus 17 over 78x plus 15 over 118, and that's my C value, and that should be the sort of quadratic or parabola of best fit instead of line of best fit.